Sycon. These are primitive sedentary aquatic invertebrates with soft porous body. They have vase-shaped cylindrical long body which opens to the exterior by an osculum. In this video, through a simple demonstration shows how effectively the sponges can pump water. In this syringe, there is a non-toxic dye known as a fluorescein. By pouring this around the base of some sponges, we can see how the water is moving. We have poured this dye around the base of the sponges and now we can see the movement of this dye. It will take a few seconds and within a few seconds the dye is being pumped through the sponges along with the water. There are the multiple ostia in the surface of these sponges and a single osculum which opens to the exterior, and the dye is being moved to the exterior of these sponges. Tube sponges are even much more spectacular to observe. The pumping action of these sponges is much furious. We can actually see how effectively the dye had came out. The body wall is thick through which monaxon, triaxon and tetraxon spicules projects. The body wall is composed of outer dermal epithelium, middle mesenchyma, and the inner flattened epithelium lining spongiosole, which opens through the osculum. The canal system is of syconite type. The chanocytes are restricted to the radial canals. Course of water current is ostia, then to the prosophiles, to radial canals, epiphyles, spongiosole, then to the osculum, and then finally to the exterior. Nutrition, respiration and excretion are by the canal system only. If we perform the same test with a hefty beryl sponge, which is a big monster like, then it will take few seconds for the dye to work. We have poured the dye around the base of the sponge, then it will take a few seconds and finally you can see the dye coming out of the osculum through this sponge. The body surface is being generally perforated with the numerous pores called the ostia, and then it opens to the exterior by an osculum.